I'm Sarah Perkins-Kirkpatrick.
I'm Iain Strachan,
And this is Totally Cooked,
the Climate and Weather Podcast. Today, our guests are Associate Professor Negin Nazarian and PhD student Ressy Fitria from UNSW in Sydney. Welcome to the show, Negin.
Thanks for having us.
And welcome to you too, Ressy.
Thanks.
So apparently Iain did some research leading up to this episode and they found out that you describe yourself as an urban climatologist. Can you maybe elaborate to our audience what that actually means?
I call myself an urban climatologist so that I distinguish between just looking at climate at the larger scale versus what we do, which is looking at climate and climate interactions at the city scale. So basically how cities are shaping their own climate and how we, people who live in the cities, are affected by that interaction. So an urban climatologist means, of course, there are all these aspects of weather and climate that are of interest, but still we put that all in the focus of cities. What is different about cities, but also how cities are maybe drivers of some of those changes.
Okay, cool. So what sort of scales then are we talking about when we talk about urban climate, and how does that compare to a non-urban climate in terms of time and space?
I think when I started the work in urban climate, maybe over a decade ago, it was very often assumed that urban climate research is at very small scale. So let's say when we look at the buildings, the street canyons, the neighborhood, the city scale. So these are like smaller scale compared to what you are looking at the global climate circles, for example, or global climate interactions. But in fact, what we're seeing now in urban climate research is that you can look at the entire spectrum of scale. You can go at very small scale interactions and buildings, but also look at how, especially like in some areas in the world where there is a large amalgamation of cities, how those are interacting with all of these larger scale processes. So there are a lot of cool research that comes out that is about tornadoes, that are about big thunderstorms and like bigger, larger processes. So urban climate research is in fact a multi-scale interaction. It's fair to say that still majority of the work is happening at the building to city and regional, but it's I personally want to point out that it's not just something that we can forget about when we go at the global scale.
So what I'm kind of picking up from that is then even buildings, like an individual building or a set of buildings in a CBD, say, can affect the local weather. Is that what you're saying?
The answer is absolutely yes. But it would depend on not just those buildings, but where they're placed. Like, for example, if you have very strong synoptic forcing or like calmer winds, all of those will change how much impact or how much of a signal they would have.
Yeah. So, it's the interaction of those buildings within that sort of normal or natural weather setting and how they interact with that to change it.
It's like a very complex system of a lot of levers that are being moved in all these different directions, right? And cities are moving the levers on very different ways. Like it might be because, there's a lot of heat. We build the cities with materials that are not natural, so they're going to generate a lot of heat. Or like humans, they just generate a lot of heat. The anthropogenic heat is a lot. So it might be that's one of the levers. You just add a lot of heat. That can be a lot of updraft. Or it can be that, these are just physical blocks. Those physical blocks are now going to stop the wind and they're going to punch a hole in a fog. How amazing is that visualization, right? Or
like Swiss cheese.
Exactly, right? So it's like the high rises are like just going around punching holes in clouds and fogs. Or it can be just because of the aerosols that we put, additional aerosols. So it's all of these different levers in cities that are going to change what is really that interaction between cities and the weather we're experiencing.
I want to jump in and ask Ressy. So you've very bravely joined Negin and her colleagues in this field of urban climate research. And I'm wondering what motivated you to do that? Why did you decide to get involved in this area of science?
At first, I really interested in urban climate because in Indonesia, I think there is still limited research in urban climate. So I want to contribute more to this research field. I think that's what made me interested.
Yeah, so it's a bit understudied where you're from?
Yes, especially with extensive urbanization in Indonesia. I think, they need more researcher in this field.
And Negin, you said that you've been doing this for about 10 years now. What drew you to urban climate specifically, as opposed to all the other parts of the Earth system that you might have got stuck into?
It's a really good question. I think I picked urban climate because I came from engineering background and then went into doing modeling. At the same time, I got introduced to climate science. One was really like at the very small scale, modeling different interactions in the flow field. And the other one was really trying to put it in the context of a really big problem that we're facing in climate change. So over time, the merging of the two and realizing that I really want to do something with all of my training and the way that I'm using these modeling tools. And I also am interested in the climate field. That was when I was doing my master's. And I think that the click for me was when I was in my PhD and I met somebody who was with the same background of modeling, interested in climate work, but was working in the Department of Architecture, which I didn't know could be a thing. And that's probably maybe 14 years ago. And that's probably like the time when I realized it is a possibility to look at things that I care about, like cities, while still applying the tools that I've learned to use and also, working on problems that I think are interesting, like climate.
When Sarah and I come to visit UNSW, we'll see Ressy and our other colleagues at the Climate Change Research Centre, but you're somewhere a little bit different. Whereabouts in UNSW would we find you and why?
Yeah, so I'm in the School of Built Environment, and also our lab is called Climate Resilient Cities. So this is by design because it's really important for us to have this interdisciplinary component that we are doing weather and climate research, but we are also really trying to be embedded in understanding what are the urban practices. So that's why the School of Built Environment is really critical. But also we have people who are coming from very diverse backgrounds, from computer science to urban planning and architecture, all the way to engineering and climate science. So it's a really good place to be between these two worlds, both built environment and the climate change research.
I'd like to ask a very general question, and I might throw it to you first, Ressy, and Negin, feel free to jump in if you want to contribute as well. But this might be obvious to some people and not to others. Why do we need to study the impacts of climate change on cities in particular?
Cities where most people live, the number of population is growing rapidly, and urban areas actively modify the local climate, as what Negin explained before. I think understanding urban climate in particular help us to design the cities to be more, to safer and more livable for the people. Yeah, if we don't study it, we're essentially like just living without knowing anything in the future.
So where you're from, Ressy, do most people in Indonesia live in cities? Is that where most of the population resides?
I think more than half population in Indonesia live in the city.
Okay.
And that would be the case in Australia as well, right? Probably more than half.
I think it's a lot more than half.
Australia is 90% living in urban environments. I think it's maybe also important to have in mind like what we call cities, because it does have its own administrative definition, right? Like, you can come and say at the global level or at the local level, we can define what should be the size based on population or based on just the footprint of the city so that we can call it a city. But in reality, when it comes to like its interaction with weather and climate, those sizes or populations are not really a metric. As soon as you change the land, there will be some interactions. You're changing like the heat, there will be roughness, like we said, aerosol, all of these aspects. So I think it's really good to have in mind that when we say cities and climate change, we really don't mean just mega cities. This is not just, if you're a really big city, you will have these problems. No, you change the land, you're going to see the effect. Those effects sometimes are going to be tiny because then you are maybe coastal and there are other larger processes happening, or it can be the same size of change of land somewhere else and it's creating bigger problem because it's changing other ingredients and some levers. So it's important to think about this is not just a big city problem.
Well, yeah, like you say, even just chopping down a few trees, or maybe not, just a few trees, like that's called land surface change, and that in itself can affect how evaporation and moisture moves through that local environment, which then goes on to affect rainfall. Absolutely. So it doesn't have to be big, tall buildings over vast amounts of area.
No. Also, I guess it depends how you describe impact and risk as well, right? So if those trees were cut somewhere where nobody is going past, also that's one level of impact, what you explained, but what if those trees are next to a playground where you're playing? And the only shade that was provided to kids that normally actually are not very sensitive about their own heat or cold, perception. and all of a sudden you also remove the shade, that's going to have more impact, not just because it's going to make it hotter, but also because these are more vulnerable people exposed to it. So we'd be a much higher risk.
I've got many opinions about that, but we might save that for another time.
We need to do a playground session.
So I'd like to talk about, do cities just experience the weather and the climate, or do they actually have an influence on it? And how do we know this?
Yeah, when you build a city, like when you replace natural surface with buildings or man-made, it's basically you change how the surface interact with the atmosphere. The surface properties, like how they retain heat or how they absorb heat, is different with the natural surface. So, for example, in terms of heat, the man-made or the building or concrete, it absorbs more heat compared to nature and hold it longer. So we feel warmer, the air warmer at night because the urban surface, release it slower compared to the nature. So that's what we feel, it's warmer at night. And it actually the urban interaction with the atmosphere is beyond the heat itself. Negin also mentioned about turbulence and also like the convection in the city, because the air in the city is warmer, it's also sometimes intensify the rainfall. Yeah, that what also Negin said. So basically it's actively reshaping the local climate. Yeah.
What about how moisture moves through the urban environment? So you talked about, Ressy, the materials that cities are built with. So I'm thinking that would therefore affect how much moisture can then get into the soil, or maybe the lack of soil. Does that then affect the water cycle? And then not just how clouds form through the buildings, but actually how much moisture might be available to evaporate and then maybe make rainfall either over the city or around the city.
I think it's also in fact affect the water cycle, because when we replace the natural with buildings, it's reduce the water storage, and also so it increase the runoff, like water flowing on the surface. And it's increased the flood risk, and also because we change the trees, the vegetation, it's reduced the evapotranspiration, like so making the city more drier. Yeah.
So I might just quickly explain what evapotranspiration is. That's that's when moisture is taken out of plants, and if there's less plants, there's less evapotranspiration that can happen.
Thanks, Sarah. Good call. And all these processes that you've just explained leads me to the magic 3-word phrase. It's one of your favorites, Negin and Sarah. Urban heat island. I'm sure people have probably heard about this in the news. Like, when we have a heat wave, there's probably an ABC News story about it. But what is the urban heat island?
Can I just say, sorry, before it's answered, it is not my favourite word in the middle of a heat wave. It's the last thing I want to be in or be near.
It's not my favorite word ever. I'm in this field who has exported this term very successfully to many people around the world who might not know anything about weather and climate, and they might still know urban heat island. So there's been a success story there.
Yeah. The phrase is good. The phenomenon itself is bad. So what is
Very
it?
bad.
For anyone who has ever wondered exactly what it is, who wants to explain it for us?
Ressy, maybe.
Yeah.
Urban heat island is the definition itself. The city, we can refer it as island. It's where the city condition is warmer than its surroundings. So you make an island. There's also another term, I think, cool island, where the city is more cooler than its surrounding. Yeah, it's because of the material and the process in the city itself making this warmer than its surrounding. Maybe Negin can add more to that.
No, I think it's very simple. Cities are warmer than their natural surrounding, and that's very often seen at night because of the materials that we use, that they tend to absorb the heat, because of the radiation trapping that exists, because of all we talked about lack of moisture and lack of evapotranspiration processes. They can be warmer, and that looks like there's a heat dome over a city that people then described it as an urban heat island.
Is part of the urban heat island effect, sorry Iain, it's my podcast now, is it also also the waste heat that people generate that can then be trapped in that really concrete-like jungle. Can that also be part of it, or is that a small fraction of it?
So one thing that is really important when it comes to urban heat island is to clarify that it's not just one effect. It's also about what you mentioned. Like, we just have this place that all of a sudden is a big concentration of all the heat that we produce because of our buildings or because of our cars or people going around. All of these combined is what contributes to cities being warmer commonly than their natural surrounding, and the whole concept of urban heat island. Ressy is correct to say that there are sometimes either in certain climates or in some times of the day where the city in fact can be cooler than its natural surrounding.
When does that happen and where? I haven't heard that term before.
First of all, I should say I do not want to popularize that term. I would like it to go on record that the urban cool island is less of a phenomenon than urban heat island. So, like, let's not popularize this one. But when does it happen? Let's go to the Middle East. One of the countries that I visited and really liked was Oman, which can be classified as, if some of the areas around the coast, you are arid coastal. Right? Already can be quite dry, it can be really hot, and then you decide to make a city there. And you also are using certain materials that maybe are close to the natural land, but now you are introducing shading and you're also introducing some level of vegetation. So a city in arid environment could easily experience temperatures that are lower than the natural surrounding. But it doesn't have to be only in that case though. And this is at the more city scale, but also it can happen at very small scale. So even cities that we're familiar with in Australia, Sydney, Melbourne, Brisbane, all of that, they could have localized areas where, because of combination of anything from there's a park and there's really nice sea breeze because it's close to the coast, and maybe also they did a really nice design, and it's giving us this thermal oasis that can be, in fact, cooler than the natural surrounding.
It's really interesting you talk about that, because I've experienced this a few times, but one I remember the most was being in Belgium a few years ago and going, they were in the middle of a heat wave. So I went for an early morning run around one of the parks in Brussels. And it was the temperature difference between running with the park on my right and the city on my left was at least 5 to 6 degrees early in the morning. It's maybe not technically the cool island effect. Maybe it's probably the urban heat island effect, because the city was still holding on that heat from the night before. But it really was quite stuck to just feel it at that small scale. Yeah,
I think this is one of the reasons that I don't think the term urban cool island is necessarily correct, because unlike the urban heat island, when it is really almost like a heat dome over a city and a lot of updraft, urban cool island sometimes is referring to this localized effect of it's intra-urban variability. Within your city, one neighborhood can be hot and one can be cooler, and those are more all these differences we see in different locations, and not necessarily higher. Mm-hmm.
Do we know how much the urban heat island effect has? What's that temperature difference that it can make? And does that change from city to city or location to location?
Absolutely. So the reported range is up to 10 degrees.
Okay.
So we have many global examples that are reporting up to 10 degrees differences. And right away, people could ask, are these happening in mega cities, or are these happening more larger population or population density? And recent literature shows no, that there is not a very clear correlation between just the population or the city size and the urban heat island. Okay. Basically, it means it is not just about how big your city is or how many people live in it, but it's a lot more at play. So one thing that we would say is it about the climate? Yes, there are some aspects of the climate. We just talked about arid cities having even a different pattern of cities being cooler, but also it's really about how the city is designed.
Yeah. So we've established that lots of people, from Sarah's kids to 90% of Australia's population, live in towns and cities around the world. Loads of people. Therefore, we must pay a lot of attention to cities in our climate models, right, Negin?
Very often it's assumed that you just heard that sentence, therefore you assume cities are just exposed to all of these problems. So it can be a downstream problem, right? and not something that needs to go in the climate model. A climate model is meant to model all of these interactions, but our city is actually like providing all of these interactions. It's just a place where people live. So no, the answer to everybody agrees that they should be included in climate models is not necessarily universally yes. And if anything, for the longest period has been like, what? Cities in climate models? Do we need them really?
Nah.
Nah. Yeah.
And so you've got this huge, huge area of settlement and land use change, as Sarah has said. And in many of the like leading climate models in recent years, if you ran the model and you could look inside it, what would a city look like?
It can actually, funny enough, you can be creative. What do you want your city to look like in those climate models? Some of them, they can be just simply a natural land cover. Others are like, no, we need to do better. Let's do a concrete slab. Because that would be a really good way of describing a city. And believe it or not, it's much better than natural land, so I'll take that. And the reality of it is that even if you're at the very low resolution of some of these climate models, there are certain things that we can do and some models have done to better describe the city. You can say just, okay, how does a city change on land? There are things about the albedo or how much the sun is reflected. You could change those parameters. We talk about roughness, which basically means how rough is the land over the city because of all of these buildings. You could change that. So first it can be, let's just better describe where the city falls. But then there's a second level of saying like, okay, in addition to that, let's also bring in the physics of it. Because we know that it's not just the land that is changing. There's something happening within that land changing. There are people living there. There are like, energy being consumed, cars going around, all of that. So now let's actually bring the physics of that and try to model it and better understand what does this mean in terms of the land surface temperature, what does it mean in terms of heat, but also what does that mean in terms of other processes, anything from wind to larger circulations. Over time, there has been an acknowledgement of not just that they matter, but also they matter because people live there, but also they have interactions. So we're slowly seeing the change in models incorporating both representation of the cities, but also the physics of cities.
I'm just thinking, when someone first pointed out to me that many climate models represent cities as, flat concrete or like there's nothing there. In Australia, that's bad enough. But Australia is a huge and not very densely populated country. But now I'm thinking about somewhere like Great Britain or Japan. Mm-hmm. Like what's the point of running a model for those areas that doesn't represent urban areas? Because the vast majority of it is urban areas, Even
if we don't focus on areas where they are majority urban, there are other parts of the world where over the last few decades, the rate of urbanization has been really large and hard to ignore. So if you look at places like China, recent reports show 300% increase in urbanization over the last 4 decades. So what this tells us is that in addition to what you said, Iain, that there are places where when you go to Europe, when you go to England, parts of Asia, where it's really, mind-boggling that we don't represent cities. But then you also see, what does that really mean? We're saying climate is changing, but look, the land is also changing at a massive rate. And if we ignore that, we're ignoring both of these components, which we've already established they have interactions with each other.
So yeah, we've talked about how important cities are and, the somewhat lack of them in climate models. Is part of that reason the issue of scale? Because even though cities can be really big, when we talk about global climate models, and we still haven't yet had an episode on them, but they generally operate on scales bigger than cities, so 1 to 200 kilometre resolution, and oftentimes cities are smaller than that. Would that be part of the reason why cities aren't often included in climate models, or is that no longer an excuse?
No, you're right. Traditionally, that has been the main argument, that these models are run at large scales with resolutions that are, like you said, 100 kilometer or more. Therefore, cities either are smaller than that or they are not really having an impact at those scales. So I want to unpack all of those things actually, because there are multiple components. One is that even if we are running at that scale and at that resolution, we just pointed out that there are nations that are, in terms of urban coverage, they are really large, and not nations, but also continents, if you look at places like Europe. And that assumption is poking some holes if you start thinking about, okay, but what would that look like if these grids, next to each other, 100 kilometer, 100 kilometer, 100 kilometer, there will be an urban impact. So resolution is, or the scale is one of the things that are being used as a main argument. But first, already at that resolution, there are some processes that has been shown that there are differences if you run a model with an urban or non-urban. But the second is that we're no longer really running at resolutions where it is 100 kilometers. The field has made a lot of effort to make these models at resolutions that are much lower than that. Let's say going anywhere from 50 to now with an aspiration of doing 10 kilometers, right? And more. That is because we acknowledge that there are a lot of processes that needs to be modeled and resolved. And some of those are related to land surface interaction, and definitely the urban effects are really critical. In my opinion, the reason that we ignored cities wasn't necessarily about just a resolution problem, but also because we were fundamentally different communities.
Yeah.
And there was not a lot of acknowledgement of how cities could potentially affect our weather. Like now we know better. We know that we have urban heat in cities and we had heat waves, and these are two components. You put them together, what you get is larger than the sum of these two. Yeah. These two have synergies with each other. Yeah. We know that cities can change rain, that you can have more rain over or downwind of the cities. We know that cities could change different aspects, including evidence coming from tornadoes and thunderstorms and lightning, which is one of the really fun new topics that I've learned that I would love to explore more, how the cities could change the lightning and the number of strikes that we might be getting. So I think there has been also a lot more understanding and acknowledgement of that effect that goes beyond just how cities shape their own small climate, but also how those go at the regional scale, and it goes beyond their physical boundaries. So there was always this assumption that whatever that cities are doing is confined within the boundaries of the cities. But now we're learning actually if a city is changing rain, that change can be actually tens, if not hundreds of kilometers downstream. So this is way beyond what happens over that physical boundary of a city.
Yeah. I remember when I first met you, and I can't remember when exactly that was, but when we were talking about urban and urban climate, like, well, yeah, this makes sense. Of course, we should be including these in climate models. Even if we can't run them at the global resolution, we should at least be doing it regionally because it just makes sense. But yeah, before that, it wasn't really a concept that I had considered simply because these two fields hadn't really interacted. So it's definitely, I would agree, it's definitely in the last few years we've really started to, the fields have really started to come together more closely, which is great.
Yeah, and I think it's maybe there were also very different methods and different ways of looking at urban climate. Going back to your very first question, what scale should we look at? Yeah. Like if a community for a long period assumed that it was only small scale processes that should be looked at, then obviously there was less overlap with another community that is doing more larger scale. And like it's only over time that they're started to merge into similar domains, similar tools, similar interests.
So, Ressy, we've talked quite a lot in the last few minutes about models, but I'm wondering what other tools do researchers use to study urban climate? And I'm thinking things like, as simple as observations and data about the weather, all the way through to fancy new things like machine learning. Can you tell us a bit about how urban climate researchers do their job?
Yeah, I think we can study urban climate in several ways. Yeah, for example, by long-term observation from meteorological stations, and also we can use remote sensing data for monitoring for a wide area, and also doing like modeling, like numerical modeling.
How does remote sensing work?
When we're doing urban climate research, we need a lot of resources either to do the modeling, or we need to set up the sensors within the cities because they are very different to the natural surrounding. And there's maybe before we even talk about some of the methods that we're using, it's important to point out how there are a lot of gaps in both the modeling and the observation. One of the biggest gaps is because what we talked about before, there has been a lack of acknowledgement of cities' contribution to their own climate and also larger processes, and therefore traditional sensors have almost never been in the cities. In fact, the WMO, the World Meteorological Organization, their guidelines have specifically mentioned areas to avoid due to contamination. And one of those is very much all of the urban built characteristics. So that's maybe one of the first things we should point out is that cities are important, but we have limited data.
So to clarify your point, does that mean that there aren't often, high quality weather monitoring stations in or near cities because they sort of
they are not.
Yeah.
Because if we look at the history of when we started monitoring even a simple weather station, very often they come through these international efforts through like the World Meteorological Organization, trying to make them streamlined around the world, and also how they might feed into like validation of the models, how they might feed into like forecasts that we do. And those guidelines, they often looked at processes that they try to make everything consistent more or less. And to do that, they had to find environments that were kind of similar in different places. And as soon as I mentioned they have to be similar, then you cannot be in a city, because then the city can make it very different. So that's why it was considered contaminated. So no, we do not really have consistent observations in cities around the world. And this is really a major issue in certain regions, including in Africa, in the Middle East, in South America. And honestly, even in Australia, we have limited observations. So we do not need to go far away.
The Bureau of Meteorology will actually move stations if they start to become contaminated. I've just taught this to my undergrads, and they actually, they keep all this metadata showing the location of each of their sites. And as soon as, it comes to encroach by the urban environment, they'll shift the station. They actually did this recently with one of the oldest records in Australia in Sydney at Observatory Hill, because it was getting contaminated. So while it's good for long-term records, it's not so great for understanding how our urban environment is changing. And even the site in Canberra is out near the airport. Great for, a very consistent record, not so great for what's actually happening in Canberra City, where it's always a few degrees warmer.
So we don't have some of these observations, and there's even an active effort of removing some of the urban observations, like Sarah mentioned. There are parallel efforts to then put sensors in cities, which is great, but also they need their own resources. So in the absence of that, there are efforts that are trying to use things like satellite. And that's really bringing these aspects of remote sensing. Remote sensing basically means that we are not sensing or monitoring or measuring at the very location that we're at, but we're doing it remotely, either using satellites that are sensing from the space, but also it could be sometimes remote sensing can be through planes or things that are just like looking above and remotely as opposed to being in that space. So that's just generally remote sensing, helping us look very often at a larger area. Satellites can be different types, right? There's some that are rotating and others that are stationary. But regardless, they will give us much larger coverage than what one sensor in a city, in neighborhood, in CBD, or in a residential neighborhood with it. They would be able to cover all of that. But also they have their own problems, which is they're seeing from the top, and maybe they're only seeing your roofs and top of the canopy. So it's really great because we can get some parameters like how the urban is changing that Ressy mentioned, how maybe there are different coverage of vegetation and built materials, as well as some surface temperature. We call it skin temperature because that's like not the air temperature. So that's not the temperature that you and I are feeling. But they're also seeing it from the top at a certain angle. They can have biases because if you have clouds, then you're not really able to see that. So they're really good because they give us global coverage. But they also can have their own issues. Are they really sensing what we sense in urban climate? And that's a big question mark. Sometimes yes, sometimes no. So it's not whether satellite remote sensing is good or bad, but it's really about what are you using it for?
Yeah.
Because it can be really amazing. Like especially one of the biggest advantage of satellite data is what Ressy mentioned, which was describing cities.
Yeah.
Can we use it to better describe the city? It's really hard.
Yeah.
Which leads perfectly to the question I was going to ask a few minutes ago, which is, historically, is Australia good at making decisions around the built environment in regards to weather and climate, Negin?
The answer is yes and no at the same time. It really depends where you go.
Really? I'd say it's a hard no. But anyway, I'm interested to hear your...
Well, the reason I say yes is because when it comes to building and the cities, who is the actor? Very often it's the council. So you can find councils that are doing absolutely amazing, that they are very clear about their tree coverage. They're very clear about when you do a new development, how much of the land can be covered by the building. There are councils that require that you do wind assessments of how much of like permeability of the wind can go through that. So the reason I'm saying yes and no is because it's a bit different than our general climate policy, because the small actors could really have an impact.
That's actually,
but where it becomes problematic is that in those good councils, all you need to do is to cross the road to the next council, and then everything can easily fall apart.
Something that I've been asked quite a lot, and I do have a very general answer, but is talking about Western Sydney. So Western Sydney is a really interesting case because of how different that climate is compared to the coastal area. It's roughly 50 kilometres inland. But I've had a few questions around what part of that is the difference in climate and what part of that is poor urban design, because it does get so much hotter out there during a normal summer day, but also during extreme heat waves. Is that like in part bad design?
Yeah. So if you look at the climate of Sydney and the temperature patterns within the more urbanized area, distance from the coast is really one of the major factors when it comes to looking at like the changes we see. So already that tells us in Western Sydney, we're preconditioned before we even put the urban effect. But it doesn't mean the urban effect is not important. If anything, it means that the choices we make in the cities are far more important than the choices we're making if you are in a coastal neighborhood. And unfortunately, that gets compounded with the fact that we've seen massive new development in Sydney. And going back to your question, Iain, of like how good we are, I said yes because of small actors, but I would say absolutely no because of lack of consistency that we have with even simple things like black roofs in a climate like Western Sydney should have been banned years and years ago. But it is not. It's now up to a council, and some councils are discouraging or incentivizing or all the terms that are being used, and others are not. Or the amount of land that we cover when we build, or how much of it can be impervious, or how much air permeability of air around. All of that is something that we should be mandating national-wide, that this is something we need to do. We have some ideas of how our different climates are interacting, so therefore we have some guidelines of climate resilient development, and we don't have those in place. So it's very easy to see a new development in Western Sydney that is, everything is built to the brim, completely, meaning that the entire plot is covered entirely by the buildings, that they're all black roofs and black materials. It might look like it's green when you look at it, but if you pay attention, some of those are also synthetic turf. And I'm not talking about the high-grade synthetic turfs that could actually be suitable for something. No, I mean the type that you can buy from Bunnings for cheap and could get 80 degrees on a hot summer day. These really compound to a problem that is already existing, which is the fact they're far from the city. So do we have a clear urban strategy in Australia? No. If you look at our national risk assessments, in fact, you'll see this is the first times we have some mentions of built environment, and even those, I would say it's a good start, but still needs a lot more to actually unpack what are the risks that we are seeing in cities. And we absolutely lack some of the guidelines that is needed for making sure that at least new developments are in line with what we need to do for our future climate.
So one of the challenges that we've spoken about there is that, cities, Sydney, for example, develops over many years, hundreds of years, and it's difficult to have a cohesive vision of how to build effectively to cope with changes in the environment. And of course, when a city like Sydney started to be built, no one was thinking about things like this. So, wouldn't it be great if someone was building a brand new city somewhere where from scratch they could think about how to integrate it into the local environment in a better way? Which leads us to ask Ressy about this really interesting, huge project that's underway in Indonesia. So many of our listeners might not know this, Ressy, but Indonesia's building a new capital city on the island of Borneo. Can you tell us about this extraordinary project and why it's happening, please?
Yeah, so there is Indonesia's new capital city being built in East Kalimantan or Borneo. It's called Ibu Kota Nusantara, or we can call it ICANN. So why it's happening? Because the current capital city is Jakarta is facing a combination of serious problems. Like the city is sinking due to excessive groundwater extraction and also chronic flooding and also really densely populated urban region there. So the government decided to build a completely new capital city from scratch on the Borneo. And why they choose Borneo? I think it's come from previously Indonesia's development has been heavily concentrated in Java Island. So moving to Borneo Island is partly to distribute the economic activity to be more evenly across other islands. So it's about mix of environmental pressure in Jakarta and also strategic development policy for economy. And in Borneo itself, I think there is also available land there, and also it's relatively central location in the middle of Indonesia region. Yeah, I think that's why they choose the Borneo. And the city boundary, the planned area there is around 2,500 square kilometers. And the development itself is staged until 2045. But the government dream about building a completely new capital city is start from the first president, but it started from the previous president before right now. And it's quite it's debatable policy about this new capital city, but and there is the execution of this new planned city is really quick. Like when they start building a new city, it's very quick. I think it's only took time 40 days to formally make this decision. Yeah, there is also debatable question about the planning itself. I think there is awareness about the including climate consideration into the planning, but I think they not fully integrate about the urban climate, like translate the scientific data into the policy. I think they haven't make fully make into the consideration about that. Like, sorry.
No, that's okay. So you're not sure if they're including things like maybe a certain amount of vegetation or canopy cover in the cities or certain building materials. That, as far as you know, is not necessarily being considered, at least not at this stage.
Yeah, I mean, for the land use plan for the building, at first they prioritized the government center in the western part. They already released the land use plan for that area. Like it mostly, not really tall buildings, but really mixed. And I think they claim that they will build a forest city, like city with the tropical forests. Yeah.
Okay, well, that's something.
Yeah.
I'd like to ask, here is Indonesia building this enormous new city in a tropical region amid a rapidly changing climate. And so, Ressy, you're studying this as part of your PhD. And what specifically are you digging into to learn about regarding this project?
So my first project is investigating how Indonesia's new capital city might affect the heat waves in the region. So I use a regional atmospheric model to run a sensitivity test, basically comparing the condition before and after the city is built. Yes, just to see how the urban development changed the heat stress experienced by the people there. Yeah, that's the general thing that I do for my first project. So yeah.
It sounds like the sort of thing they should have checked before they started building it.
Yeah.
Yeah. I think it's good if it's better to have like the sense, the extent of the intensity that will happen if we build a city there. Instead of not knowing everything. Yeah, there is a limitation in my study, of course, because we cannot validate the model because there is no observation data in the city it's not fully existed. So but we can just provide the sense of extent, how much it will change.
It's but you said, Ressy, earlier on that this city came about within 40 days that the agreement had settled on, and that's hardly enough time for the government to do their own research or commission research to be done. So I think it's really great that you're doing your PhD in this area because it's such an important topic. But yeah, it's interesting that they're relying, it has to be relied on academics to do this research, and it's not necessarily something that the government looked into themselves.
Well, I was going to ask actually, yes, the work that you're doing is kind of an educated estimate based on your analysis lacking some of those observations that we might like to have in that area. But what do your projections say about how, the climate is going to be and how things like heat waves are going to be in this new capital city?
For me?
Yes, please.
Yeah. So from my result, the results show the temperature increase as expected because the urbanization, but the humidity drop at the same time. And it affect the heat stress that experienced by the people there because it's influenced by temperature and humidity. And we found that the area near the coastal, it's intensified the heat stress, but in other areas, really spatially heterogeneous pattern. Like there is a decreased pattern, there is also increased pattern, but mostly on the coastal area is more homogeneous pattern, like it's warming. Make it worse for the heat stress.
Consistent warming near the coastal part of the new city, and then a little bit inconsistent in other areas.
So I run several heat waves. Most of the heat waves showing on the coastal area, the heat stress was worse.
So you just said then, Ressy, that you ran some heat waves.
Yes.
How do you create a heat wave to run? Firstly, how do you define it? And then what might you change to test what's going to happen over the city?
So I identified heat wave events using heat index factor, and I chose several days of them, and I run for the control, which is the pre-development condition of the area, and also run for the experiment when I put the city there. And I run for those 12 heat wave events and compare the outcomes of.
So it's just basically the heat wave with and without the city based on some sort of climatological definition.
Going back to this concept of smart cities, and in this case, smart forest cities, Negin, I know that you and some of your researchers look into things like this, but I'm wondering how effective are things like urban greening or cool roofs, ventilation corridors, these kinds of mechanisms that we might be able to integrate into the built environment? Do they make a big difference or not?
Do they make a big difference on human heat stress? Absolutely. They make a big difference on some of those larger scale processes? Not always. A lot of these strategies are for the right reasons of making sure that, especially during the extremes and extreme heat, that people are still experiencing thermal conditions that are not too dangerous for them. So if we give them some localized, these oases that we talked about, right, that we give them some localized area comfort, then that can reduce their exposures and experience of heat. So they can be effective in that context. They can also be effective sometimes for bringing down our energy demand, especially for cooling for neighboring buildings. But a small scale greening project is not going to be a silver bullet for a lot of challenges we're experiencing in cities at the larger scale.
Or even a green bullet.
I think that's actually a really important point, that a lot of these urban strategies are great for how we feel, but they're not going to solve climate change, or they're not going to solve some massive problem. They're just going to make us better adapted to those conditions.
Absolutely. So they are really good adaptive or adaptation strategies, but obviously cities need more larger scale mitigation or reducing their emissions. They also need better holistic ways of designing than just localized way of looking at the problem. And this is especially a thing that is needed for future, because we know that it's not just that the future climate is changing, but also we're going to have more people, which means future cities are going to change. And the way we do it will have a really big say on what outcome we have from both of these components. Interesting to point out, isn't it interesting that we're thinking of all these like smart new ways of doing things?
Yeah.
But in fact, all we need to do sometimes is to look at traditional architecture, because people have lived on this planet and have managed to find ways of living in harmony with the climate in different parts of the world. So sometimes it doesn't have to be that new smart, forest setups. It can just be going back to how we've done things in more harmony.
Well, that's the thing, right? Like, we're talking about smart forest cities, but really it's nature. Like, putting more trees around, of course, is going to create more shade and a cooler environment. It's not that big a concept or that radical of a change to go back to those basics.
Yeah, unfortunately, the climate is changing, though. So it's worth pointing out that there are a lot of studies showing that in future climates, some of these adaptation strategies at the city scale are going to fall short. Their effects, the things that they're going to improve is not going to be as large as some of the effects we might be seeing. Not to say that we should get discouraged and not do those, but have in mind that their effect in the future climate might be a small portion.
So, moving on to the final section of the recording, I'd like to ask about the future of urban climate research. So perhaps, Negin, you might like to answer this first. What would you say are the biggest priorities in urban climate research?
Really good question.
Thank you.
So I think there are two sets of priorities, I would say. One is looking really inward about the community and the scientific community and what needs to happen. And the other one, to me, it's parallel to that, is with everything we know already, even without changing anything or learning new things, how can we better create more actionable urban climate information? So there are slightly different things, because you could argue that we already know a lot, but for many reasons, they are not necessarily actionable. So what do I mean? It's not just about whether the data is available. Sometimes that's a problem. The problem is that we don't have access to the data. We don't have access to the models. But other times it's simply because they are not turned into the same language or the same metrics that a designer is using, or a person who is making decisions about different plannings in the cities that we're using. So it's good to have that in mind before talking about also what's the future of urban climate, because I think there's a lot that is really about how can we create information, or urban climate information, to be more specific, that can really give the answer at different scales that practitioners and policymakers and so on. The field itself, we talked about some of the inequalities that exist in access to data. And I think that's really critical, because a lot of cities around the world that are vulnerable to climate risk are the same cities that don't have the amount of data or even modeling capacity that is needed. And this is a really big challenge, but maybe a good segue of some of the opportunities that are currently coming. We're using a lot of machine learning and AI these days to see what if I learn from a city that is really data rich. Let's say one of the Australian cities has given us the opportunity of grabbing data from even a sensor that you bought from Officeworks and put in your office. maybe I can grab that, and I can grab the information from our fancy models, and I can try to train a machine learning algorithm that can give me things a bit quicker. So you don't need an expert like me, or you don't need a lot of supercomputers. You can just quickly try to create a map of wind or a map of temperature. So that's cool already on its own, just being able to see if we can do that and how accurate it is, what does it mean in terms of extremes, figuring that out. But it also has implication in filling the gap in other places. Can I actually use what I learned in a city like Sydney and now come and say, wait, what if I try to apply that to somewhere with similar climate, with similar characteristics, another coastal city that might be able to use this method to better understand what are the patterns of temperature or wind and other things. So I think there's of course, as one of the many things about the future of urban climate is to better understand how to fill the gaps with things like machine learning.
So there was a conference that Negin and I were at a number of years ago now, the same conference actually, where they were talking about injecting aerosols into the atmosphere for global dimming in the plenary. But anyway, there was a session, Negin can explain more, but one of these researchers got up and basically said that the cities are rock. So since then, Negin's famous quote is, "The cities aren't rocks."
I wish it was just as simple as like that. We knew that from the beginning, but I remember very well, we rushed to that because it was like, wow, there is an urban session. Amazing. We all sat there enthusiastically waiting to hear the urban results, only to be told at the very last slide of those presentations that, by the way we considered cities was by considering that they are rocks. So that started a whole campaign of cities not a rock, which is the future of urban climate research, I would say.
Forever, I will know you by that line.
And Ressy, I'm interested to know what you think the future might hold for you. So you might not know yet, but could you see yourself working in academia in urban climate research like Negin? Or might you consider working in industry or government to try and convince them that cities are not rocks? Do you have an idea yet of where you'd like to take this?
Well, I will work in academia because actually right now I'm already working in one of university in Indonesia. So I will be back and working there later after I finish my PhD. So yeah.
Yeah, brilliant.
Do you see yourself living in the new capital city?
And no.
Why
too
not?
hot?
Why not?
Yeah,
not
too hot.
It's
Gosh,
too
if it's
hot,
gonna,
I think it's not. Yeah, I don't know.
if it's too hot, then they've already failed at making it climate resilient for the future, I would imagine. It's not very encouraging.
And Negin, you said that you kind of hope that as the science gets better, then the people who can use it will start to listen more. Do you think that that governments and construction companies and urban planners, do they take urban climate change research seriously? Are they listening, or does that need to improve as well?
Yeah, it definitely needs to improve. Sometimes they're just simply not listening. Other times it's that there are a lot of competing interests. So if you are a politician and you're told that your biggest problem to fix for this round, which by the way is only probably 3 or 4 years, is housing and like different aspects of economy. And then at the same time, somebody like me comes and say, hey, you need to also pay attention to the heat and the flood and all of that stuff. Unless we actually have had a major flood that made people angry, which is a different scenario, but very often those other competing interests get in the way. So definitely we need people who are making decisions, and that can be really across so many levels. It doesn't have to be only at the high levels of global federal government, but we really do need people to understand what is at stake and what is the impact, and be able to then put that in the context of all these other interests that exist. And I think there's still a lot of good arguments around why they should be looked at together with those and not just set aside as 5th or 6th priorities that could be ignored.
I also have a question which I'm going to ask because Sarah, you might like to answer this one with your like academic, research hat on, because it relates to some of the things going on in your group. So thinking about equity and urban heat and humidity exposure is rarely evenly distributed. Socioeconomic differences, green space access, housing quality, that strongly shapes who suffers the most during things like heat waves. Do you think that's something that we're tackling seriously as a society, or is it not a high enough priority yet?
I would say the short answer is no. I feel like it's increasing in priority as we have more and more information coming out about how humans respond to heat, who's living where in a city, and how vulnerable they are, not just in that broad scale environment, but also within their homes. But I would argue it's not as much of a priority currently as what it should be, and that priority is only going to increase in the future. That's me. I'll let the other two, our guests, say.
I think it's good to see that that over the past decade, I would say there has been more growing acknowledgement of not just looking at how hot it is, but also who is going to be exposed and what their risk. Because those are different questions. You can say it's really hot, but we still manage to keep the public awareness up. We plan for it through our different design strategies, but also even in terms of emergency response and all of that. And therefore that we're bringing our risks down. So basically it's really hot. Nobody's going to be outside and everybody has air conditioning. Maybe we shouldn't care about, right? But it's a very different question, a different setup that we're in. We're not in that. So it's getting hot, but we also have vulnerable people that are exposed to it. And not only air conditioning is not always a solution, but also many people don't even have access to it, or there's energy poverty and so many things that means that it cannot be the final solution. So there's absolutely more acknowledgement of that as a concept, but I totally agree that it's not as high a priority as it needs to be, given that I just pointed out, even with us deciding now that let's create better designs and better adaptations in cities, we know that they are not going to be sufficient in some of the future climate scenarios that we might see. So it needs to be higher up in the priority. And it's very interesting to see that in some cases, when we do see some of these guidelines, let's say guidelines for better design for heat or better design for climate in general, when those are being used, they also lead to higher property values.
Yeah, that's true.
Which would actually make it even more out of reach for part of the community that needs it the most.
That's really depressing.
And actually, in fact, some developers are using it. It's very interesting. I have worked with one recently where they were very cautious about that. They want to design with our knowledge and evidence of how to keep things cool. But later, we also saw that was a big part of their promotional campaign of why their price tags are very high.
Wow. The little
cheeky.
That's very cheeky. That's really, yeah.
Let's end on an optimistic note. Negin, perhaps you might like to give our listeners a little whistle-stop tour of what 21st century weather is doing to advance the field of urban climate research.
So first, we need to acknowledge that one thing that is really positive to see in the Center of Excellence for the weather of the 21st century, it's just the fact that we have urban-focused research as part of our agenda. That urban modeling is part of our modeling visions for the 21st century, that we have different students, different chief investigators, different people, also with different partners, are looking at urban problems. So that already is a really, really positive note. We had 2 previous centers of excellence with focus on climate research, and we did not have that. So it's really good, privileged place to be in. And there are some really cool projects happening. We're looking at, for example, how in Sydney, the development of Sydney might have changed hail. I mean, that's cool, isn't it?
That's really cool.
We have projects like Ressy's that are about heat waves and rains and about uprooting these cook cities and taking them different places. And what does that mean in changing the weather patterns? Also, we see a lot of machine learning work, which I'm quite excited about, not because it's going to solve all of our problems and the world hunger while we're at it. At the same time, a lot of people want to sell it as that like AI and machine learning is going to fix all of that. No, that's not what I'm interested. But I think it can scale some of our work to other places so that we also scale the impact as well. So I'm quite excited about that.
Brilliant. Thank you.
And yes, the future of urban climate is also understanding cities are not rocks or concrete slabs.
We got there in the end. I was wondering if you're going to bring that
up.
up.
There in the end.
I almost said it. I'm like, no, this is Negin's line. I can't take
living, breathing entities that are dynamically evolving. And yes, the future of urban climate research is all of this being better acknowledged and integrated into everything we do at larger scales.
So grateful for both of you giving us so much interesting information and insight into how urban climate research works. That's it for today.
A big special thanks to Negin and Ressy for appearing on our show.
Please join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.